Okay, so today actually we got some good news and bad news. Which news do you want to hear first?
Bad news.
Bad news. Okay. Bad news is today we have exams. We have a 1 hour exam. And the good news is we're not having before class quiz and after class quiz. And also next week we're not having lessons. So I know you are having a term break next week, right? So enjoy your holiday. Okay, so but before the exam, I will do a revision session for 40 minutes. So please pay attention. The revision session will cover some of the topic that is tested in exams. Okay, now we'll test it on the first 6 lessons about what we have learned. Okay, so let's take a look at the revision session now. Can you see the oh no. Oh, just wait a minute. Okay. Let's check. Alright, so let's take a look at today's lesson. We're going to do a revision. First of all, let's think about in lesson 1 what have we learned. We learned about the 2D division, right? So let me give you an example. For example, for this 91 divided by 13, how would you solve this division? Christelle? List down. Okay, very good. So that is one method. We can list down. But first of all, let me write down the column form. 91 divided by 13. Okay, so Christelle, can you tell me how to list down? 13, okay. 13 times 1, this is 13. Now, oh, then 13 times 2, okay? 26. Oops. Now, our goal is to find out what? So 13 times 1 gives us 91. Okay, now we get 26. Shall we continue? Okay, let's continue. How about 13 times 3? What does it equals to? 39. Now again, we are quite far from 91. Yes, we should. You know the answer. Later I'll ask you. Okay. So then let's try another one. 13 times 4. This will give us 52. So is 4 our answer? No. Okay, this time our last solution. Can you tell me the next one? 13 times 5. This will give us 65. No, so 13 times 6, this will give us 78. So just add 65 by another 13. Then 13 times 7, this will give us what? 91. So the answer is 7. Perfect. Now if I want to put the 7 as an answer, where should I put it? Should I put it above 9 or above 1 here? Above 1, because this 9 cannot divide 13. So we'll put a 0 over here, and then you put a 7 over here. Now 7 times 13 equals 91. Then there will be no remainder. So for this question, the answer here is just 7. Now, except for listing down method, are there other methods that we discussed in class? Does you can think of one another method to show this division? Okay, now let's think about this. You're trying to find out 13 times what give you 91, right? Now let's think about this 1 here. It is determined by which digit? Yes, so this 1, okay, let's try to come up here. 3 times 1 equals to 3. 3 times 2 give us 6. 3, 9. 3 times 4 equals to 12, and the last digit is also 2 here. Now 3 times 5 equals to 15, the last digit is 5. 3 times 6, the last digit is 8. Yeah, 3 times 7, the last digit is 1. So you see, this 1 here, it is only determined by which 2 digits? 3, yes, it is only determined by this 3 and this question mark, right? So to find out the answer, you can analyze the last 2 digits here. So to try to find out 3 times what, the last digit is 1. So 3 times what, the last digit is 1? Yeah, 3 times 7 equals to 21, the last digit is 1. And then you'll find out that, then you still need to do a check. So if 3 times 7 equals 21, let's check if 13 times 7 really give us 91 here. Then 3 times 7 equals to 21, the third digit 2. Then 1 times 7 plus 2 equals to 9. So indeed, 13 times 7 equals to 91. So 7 is the answer we want. Now this method is called what? If you remember the analyze what digit? The last digit of these 2 numbers, right? So it's called the last digit analysis. Do you remember? Okay, so this method is called last digit analysis. But then we still have another method. We can make some estimation. Because you see here, we start from 1 to do this down. But then, we can do some estimation to find out the starting point to make our calculation simpler. Bernice, do you still remember how to do the estimation? Can you tell me? For example, 91 divided by 13. 90, you can estimate it to be what number? 91 is close to what? 90. Okay, so we estimate it to be 90. For 13, it's close to which number? 10. Okay. So we estimate this one to be 90, this 13 to be 10. Then we do a division. Based on our estimation, this value should be 9. So then we can use 9 instead of 1 as our starting point. So we first guess 13 times 9. Will this actually give us 91? Okay, let me write it down in the column form here. Bernice, can you tell me what is 13 plus 9 times 9? 3 times 9 equals to 27, so it's a 7 and a carry digit 2. Then 1 times 9? 11, perfect. So is 9 our answer? No. Then this equals to 119 is not our answer. Then let's move on. What is the next step, Bernice? Times 8, excellent. 13 times 8. Now let's check. 13 times 8. This will give us what? 3 times 8? 24. And then this number? 10, excellent. 13 times 8 equals to 104. Now, is 8 our answer? Again, no. So what should we do next? Okay, we do 13 times 7. You minus this 8 by 1. Now this time, you'll see that it will equal to 91. So you see, with estimation method, we first make an estimation to find out our starting point for the guesses. Then you only need 3 steps. But if you use 1 as a starting point, you need 7 steps. So this is called the estimation method. Okay, so these are 3 methods. So yes, Rishi?
How to tell which one is closer?
How to tell which one is closer? Because you see, when doing estimation, you estimate this to be 90, this to be 10, then this 9, it should be quite close to your answer. Because when you are doing estimation, this is your result based on the estimation, right? But then if you always start from 1, you don't know how many times you need. Okay? So these are 3 methods. And also we have introduced another method. But this time I'll show you another example. Let's say 360 divided by 90. How to solve this question, Christelle? Like the things I asked you. Take away 2 0. So in your divisor and your dividend, if you have 0 here, you eliminate the same number of zeros. Yes, 36 divided by 9 equals to 4. So it's just as simple as that. You see, if there are some 0 in both your dividend and divisor, just take away the same number of zeros. This method is called what? Richard? Any idea? It's called zero elimination method. So you eliminate the same number of zeros. Okay, so that's all about lesson 1. Let's take a look at lesson 2. Oops. So in lesson 2, we have to take a look at small calculation, right? First of all, let's take a look at how to solve this equation faster. Ziqi. Any tricks to solve this equation? Okay.
I know. Find which 2 numbers can give you a very good.
Yes. Now, which 2 numbers they give you a very good number?
46 and 54.
Yes, 46 and 54. They add up to what number? 100. So you add these 2 numbers up together first. And then you get 199 plus 100, and you'll get 299. So this method we call it find friend number first. Because when doing addition, the friend numbers 6 and 4, they add up give you a very nice number. Now what else friend numbers are there? Bernice, can you tell me what else friend numbers are there? You know what friend number means? It means they combine get to 10, right? So, for example, for 1, what is its friend number? 9, excellent. How about for 2? 8. And then for 3? 7. 4? 6, perfect. 5? 5, excellent. So these are all the friend numbers. When doing addition, try to combine this pair together. Then you'll get a very nice, like 110 something. Okay, moving on, we have also take a look at some subtraction here. This time Bernice can explain to me, are there any tricks to solve this equation? Okay, you see, 117 plus 54 minus 17. Of course, you can add them together first. But you see, 17 and 17. So if you're doing the subtraction first, you move this in the front. This will give us 117 minus 17. Then you plus 54. What is this result? 100. Very good. And then plus 54. Then you get 154. So you see, when you are doing subtraction, when the numbers they have the same last digits, then try to subtract them first. Okay. Then find the same last digit. And also we have to take a look at some continuous subtraction. Christelle, can you tell me how to solve this faster? Very good. So what Christelle says, we can use 182 minus the sum of these 2 numbers. 45 plus 55. This will give us 100. So you will get 122 just minus 100. And the result is just 22. Okay, so continuous subtraction equals to minusing their sum. And we have also take a look at some division here. Okay, Rachel, can you tell me how to solve this equation faster? Okay, so remember when we are doing continuous division, equals to dividing the what? Okay, no worries. Let's say I have 100 apples. I want to separate it into 2 classes. Class 1, class 2. Then for each class, class 2. For each class, there are 5 students. Then, how do we find out for each student how many apples they have? What? Sorry? 5 plus 5. Okay, 5 plus 5. Divided by is 100. Excellent. Now, except for 5 plus 5, because each class has 5 students, right? You can also use 5 times 2, right? Because 2 classes. Now, then you use 100 divided by this 5 times 2. But then you can also do it like this. We have 100 apples, we shall distribute to 2 classes. So 100 divided by 2, this will give us what? For each class, how many apples are there? 50, yes. Then after you obtain this result, we further divide this by 5. Because this is inside each classroom, how many apples are there. Then I want to distribute these apples to the students in each classroom. So these 5 students. So you see these 2, they are equivalent. So dividing 2 numbers is called dividing the product of these 2 numbers, right? Okay, now back to this question. Let's take a look. If you are dividing 4 and dividing 25, you are dividing the what of them? Sorry, the what? Difference? Okay, so you can think about this. 3700 apples. Okay, 3,700 apples. Now you have 4 classes. Each class has 25 students. Again, can you tell me how many for each student how many apples will you receive? So 4 classes. Oh, 25 times 4. This is the total number of students, right? And then you use this 3700 divided by this number. Okay, perfect. Now you see, dividing 2 numbers continuously equals to dividing their product. So this will actually equals to 3700 divided by 4 times 25. What is 4 times 25, Ziqi? Yes, 100. So you see, 4 times 25. If you don't know 4 times 25, let me list it down. 4 times 5 equals to 20. So carry digit 2. 2 times 4 plus 2 equals to 10. So 4 times 25 equals to 100. 4 and 25, again, this is a very important pair, you need to remember. So when doing multiplication, you combine them first, then you get 100. Okay, then this will become 3700 divided by just 100, and then you'll get what? 37. Okay, again, continuous division equals to dividing their product. Okay, moving on, we have also taken a look at something like this. There are addition and there are multiplication. Now, Bernice, can you tell me any idea to solve this faster? Uh, 36 plus 64. And then 5 times this number. Perfect. So this will equal to 5 times the sum of 36 and 64. Now this will equal to 5 times, what is the sum here? 100. So the answer should be just 500. So you see, in this question, we are given multiple multiplication terms. They are adding up together. Now, if in each of these terms there is the same value here, then you can extract this factor out. We call this the extract common factor. Now, if you still don't understand this, you can think of it like this. We have 36 5. Here we have 64 5. So we try to find out in total how many 5 are there. So you add these 2 numbers up. These are the total number of 5. Then times 5. This will give us the total value. Okay. Now moving on, in lesson 3, we are thinking about the word problems. Now in word problem, first of all, we have taken a look at the very basic sum and multiple problem. Now let's go and read this question again. It says Mary has some beads. Now Lena has 3 times as many beads as Mary. The 2 girls have 2,100 beads altogether. How many beads does Lena have? Now first of all, let's recall when drawing the model, we should draw a model based on which information first? Christelle? Based on the 3 times. And starting from which item? The smaller one or the larger one? Yeah, we'll start from the smaller one. So this time, Mary has smaller. Mary, let's say Mary has 1 unit. Then this Lina will have 3 units. And we are given the sum, which is 2,100. So to find out 1 unit, what should we do? Richard? So use 2100 divided by 4, right? Excellent. So that's how I find out 1 unit. Now for the calculation step, I'll skip for now. Just let's move on to the next question. Moving on, we have to take a look at some variation of the sum and multiple problem. Let's take a look at this question. Oh, first of all, let's do a quick summary. In sum and multiple problem, the first thing you do is to draw smallest item, then you draw larger item, then just find out the units and the sum. Because this problem is called a sum and multiple problem, normally you have the multiple and the sum. Okay, then we have to take a look at the variation of the sum and multiple problem also. For this question, let's try to solve it together. It says warehouse A stores 90 tons of grain and warehouse B stores 160 tons of grain. How many tons must be transported from warehouse B to warehouse A in order to make the grain in warehouse A 4 times than in warehouse B? Any idea how to draw the model in this question? We should start drawing from A, okay? Now A has 4 times than in B, right? So which one is smaller? B is smaller, so let's draw from B first. Let's say B has 1 unit. Then A has how many units? 4 units, perfect. A will have 4 units. Okay, we're ready to here. 1 unit, 1 unit, and 1 unit. Okay. Then this is a scenario at what time? Is it before or after? After, perfect. This is a scenario afterwards. Then we are given the multiple relationship now. What else information are given to us? Yes, the total. The total is what?
160 plus 90.
Yes, that means before and after giving out the grains, the total remains unchanged. So before, the sum is 90 plus 160. Afterwards, it remains the same. So this sum here is also 160 plus 90. The sum is 250 tons. Then you should know how to solve the, can you tell me how to find out 1 unit?
So 5 units, 250.
5 unit is 250.
So 1 unit is 150 divided by
Excellent. So 1 unit is 250. Just divide it by 5. This will give us 50 tons. Then the question says, what are you asking for? How many tons must be transported from warehouse B to warehouse A?
So it's 3 units.
Let's think about how many tons must be transported from warehouse B to warehouse A, right? First of all, we know 1 unit is 50 now. So that means afterwards, B has 50 tons. So how many tons has been transported from B to A? So that
160 minus 50.
excellent. So at first, B has 160. At last, she only has 50. So we can use 160 minus 50 to obtain the value transferred. This is just 110 tons. So see, in this kind of question, there are 2 identities and they are transferring values between each other. But before and after transferring the value, your total remains always unchanged. So this is a very important property. Everybody, please just remember that. Okay. So during item transfer, the total remains unchanged. Now moving on, we have also take a look at another variation of sum and multiple. You see, in this question, the total mass of 2 packets of sugar and 3 packets of flour was 8 kg. The mass of 1 packet of flour was twice as heavy as 1 packet of sugar. What was the mass of a packet of flour? You see, in this question, there are some repeated identity here. There are 2 packets of the same sugar and 3 packets of the same flour. Then, how should we start drawing the model this time, Bernice? Okay, again, let's try to recall. We draw the model starting from which condition? Multiple. Where is the multiple condition? Twice. Now, flour was twice as heavy as sugar, so which one is smaller? We should start from which item? Sugar, perfect. So you just starting from 1 sugar. Let's say 1 sugar, it has 1 unit. Then for the flour, how many units does it have? You have 2 units, perfect. But are we given the sum of this 1 sugar and 1 flour? No, what are we given? What information are given to us? Total mass of 2 sugar and 3 flour, right? Then how can we represent 2 sugar and 3 flour? Another model, okay. First of all, how to represent 2 sugar? 2 units. You just duplicate this bar by twice. So 2 units. 1 unit and 1 unit. Then how can we represent 3 flour? How to do this 4 units? 2 times 2. How many flour do we have? We have 3. Each flour has how many units? Each flour, take a look here. Each flour, 2 units, right? So in total, how many flour do we have? 6, perfect. So 3 times 2 equals to 6. So you draw 6 bars for the flour here. Oops. 4 and 6. Okay, just save time. I just write 1 U. And we are given the total mass of them, right? So this is 8 kg. The total mass here is 8 kg. Then to find out 1 unit, it should be quite simple for you now. Okay, so I just skip this step. Alright, so you see, when there are multiple identical items here, what we can do is to first draw the model for one of these items, and then you just duplicate these bars. Okay, just duplicate the bar. Alright. Now in question stage, we have also take a look at a very long question. Okay, let's try to draw a model for this question again. The store delivered a total of 53 kg of the oranges, apples, and bananas. The weight of the oranges is 3 kg less than 3 times the weight of the apples. The weight of the bananas is 2 kg more than twice the weight of the apples. How many kilograms do the oranges weigh? Okay, so for this model, for this question, how do we draw the model here? Christelle? Apples 2 units. Apples 2 units. First of all, let's check. For the first line, the weight of oranges is 3 kg less than 3 times the apples. Now, between apples and oranges, which one is weight less? Apples weight less. Okay. How about for apple and bananas? Apples also. So we should start from drawing apples because apple is less. Now, let me draw a bar for apples. This apple you have 1 unit. Then, how many units will the bananas have? 2 units. Is that all? And 1 unit, but 3 kg for bananas. Right, for bananas. Oh, 2 kg more than the 2 times of apples. So we have 2 kg more. How about for oranges? Enjoy it. 2 units as well. Yes. But another one is half a unit. How do you know it's half a unit? Oh, about half. Okay. Let's go about half. Then total is 53, yes. But we have 3 kg less than 3 units, right? So let me draw a dotted line here. This represents 3 kg. Then this total here is 1 unit. The total is, of course, it is 53 kg. Then how do you find out 1 unit here? Yes! So you see here, we have 3 kg less. So to get this complete 1 unit, you need to add this 3 kg back. So 53, you plus this 3 kg back. And then for this 2 kg, because it's small, so we can eliminate this 2 kg by minusing it. Okay, so you minus this 2. Then you get 54 kg. Now this 54 kg corresponds to this 1 unit plus an extra 2 units over here. Because you see, we minus this 2 kg already. And then plus these 3 complete units. Because we already add back this 3 kg. So 54 corresponds to 1, 2, 3, 4, 5, 6 units. Then you'll find out 1 unit. Okay, so in summary, in this sum and multiple problem, let's try to think about what characteristics does it have. It have a sum and also have a multiple. Then, what kind of type of question are there? First of all, it's the quite basic one. You are directly given a sum and multiple. Let me erase this first. Okay, and the second type is you are given some two items that are transferred between each other. Then the total remains unchanged. In the third type of question, you are given some repeated identity, some repeated items. Then you just duplicate the bars. And in the fourth type of question, this type, again, the multiple, they are not directly given. Some value they are more and some value they are less. So if there are some value more, then you minus the total by it. If there are some value less, then you add the total by it. Okay, that's all for the sum and multiple problem. And moving on, we'll take a look at the difference and multiple problem. So again, a very basic question. The difference in the value between two numbers is 480. So and then one of the numbers is 3 times the other number. Again, we start drawing from the multiple relationship here. So this one, the smaller one is 1 unit. The larger one, it contains 3 units. And then we are given the difference is 480. So you draw a difference over here. This is 480. So see, in the difference and multiple problem, you are given their difference and their multiple relationship. So you use the number of units this and the corresponding difference to find out 1 unit. Okay, so that's the typical difference and multiple problem. Again, I'll skip this step for summary. And then we have to take a look at some variations. Let's read the question together first. Cindy and Tina, they had the same number of bits at first. After Cindy threw away 24 bits, and Tina bought another 84 bits, Tina had 4 times as many bits as Cindy. How many bits did Cindy have at first? Zizi, can you tell me this time how do we draw a model for this question? We draw the model at first? Oh, the smaller one. Which one is smaller? City is smaller, perfect. So city, okay, S is smaller. City has 1 unit. Then how about Tina? Tina got 4 units, perfect. Tina got 4 units. This is scenario at what time though? After, perfect. This is the after scenario. But then before what happened? So at first they have the same number of bits, right? So let me draw a model for the before scenario. Before, these two persons they have the same number of bits. CT had this amount of bits, and Tina also had this amount of bits. But then what happened is CT threw away 24 bits. So CT threw away this number of bits, 24. This has been thrown away. And Tina bought 84 bits. This was being bought. So the new difference is what, Ziqi? Can you tell me?
The new difference is
This difference, after throwing away 24 and after gaining 84.
24 plus 84.
Yes, 24 plus 84. So the new difference is 24 plus 84 equals to 108. Now after CT threw away and after Tina bought, their difference is actually how many units though? Tina has 4 times as many bits as CT. So yes, so what is the difference in terms of unit?
So 3 units is 100.
Excellent. You see, this is the difference afterwards, and this will equals to 108. So 3 units equals to 108. Then 1 unit equals to 108 divided by 3. So just that simple. Okay, so in summary, if they have the same number at first, they have 1 loss and 1 gain, then the difference equals to the loss value plus your gain value. Okay, so they have the same at first. Now 1 loss, then this part has been lost. 1 gain, this one has been gained. Then your new difference is over here. It is a loss value plus your gain value. Okay. Moving on, let's take a look at another variation. Let's read this question together first. Now, Mary had 166 and Larry had 304. Each of them bought 5 similar plates, then each of the plates they bought was of the same price. After buying the plates, Larry had 4 times as much money as Mary left. Okay, first of all, how about let me draw a before scenario here. So, before, we see that Mary has 166, right? So Mary will have $166. This total is 166. Then for Larry will have $304. Oh, let me draw a longer bar. This total money is 304. Then what happened, Bernice? They bought what? They bought 5 similar plates. So to indicate these 5 similar plates, first of all, these 5 similar plates, they have the same cost, right? So that means both Mary and Larry, they spend the same amount on these plates. So we can draw a bar over here to represent the cost for these 5 plates. So this amount has been spent away by this Mary and Larry. Then, what is the relationship between the part that is being left? Any idea? For the part that is being left, what is their relation? Oh yeah, this is a difference, right? And then Larry had 4 times as much money as Mary left. So that means this part is how many times this part? 4 times, excellent. So let me draw a model here. 1, 2, okay. Let me extend this. 3 and 4, they are actually 1 unit, 1 unit, 1 unit, and 1 unit. This 1 unit. And what Bernice just said is the difference over here is 304 minus 166. This will give us $138. Oh, let me add a dollar sign. $138. Then how do we find out 1 unit? Excellent. So 3 units are equivalent to 138. So you see, in this kind of question, they all spend the same amount of money. Although we don't know the exact value for these 5 plates, but when you're doing subtraction, these 5 plates, they will be cancelled out. So the difference always remains unchanged, no matter how much this plate is. So we call this fourth question the common decrease problem. Okay, so when doing common decrease, you can ignore the common decrease part when finding the difference. Okay. Alright, and also in question 5, I think for this question I'll just stick for now, it's quite similar. So in repeating identity problem, again, you can ignore the repeated items when computing the difference. Alright, moving on to lesson 5, we finally reached the fraction part. First of all, we try to find out the equivalent fractions. Christelle, can you tell me how to find out the equivalent fraction for this 2 over 5, or 5 over 2? 2 times 5 equals to 10. So 5 times 5 also equals 25. Perfect. So if you do the multiplication in both your numerator and denominator, or you do the same division in both your numerator and denominator, you get the same equivalent fraction. And moving on, we'll take a look at an improper fraction like 3 over 2. Ziyi, can you tell me what is the characteristic of the improper fraction? The bottom is bigger than the top.
The top is bigger.
Yeah, the top is always bigger than the bottom. And also, it can be like this. The top is the same as the bottom. This is also called the improper fraction. Alright, and then we'll take a look at the mixed number. So a mixed number, it contains 3 numbers here. The whole number part, the numerator, the denominator, and the numerator. Okay, so this actually represents 3 plus 1 over 2. Alright? And then we'll take a look at how to do the conversion between the mixed number and improper fraction. Richard, can you tell me? For this 3 over 2, how do you convert it to a mixed number? 1 and 1, 2. How do you know it's 1 and 1, 2?
Because you use 2 times 1 equals to 2, but after that you can't really add into anything else into the tree anymore.
Okay. So what it said is that we put a 1 over here and it's 1, 2. So see, for this 3, it can only contain 1, 2 here because 3 divided by 2, you get the quotient as 1. And then you also have a remainder of actual 1 here. So your remainder is put above here as a numerator. And your whole number here is put as here as a whole number. Okay, then how do you convert from mixed number to an improper fraction, Bernice? Can you tell me how to convert this to an improper fraction? 3 times 2 plus 1, excellent. This will give us 7. Where should we put this 7? Should I put it above or below? Above. How about this number below? 2, excellent. So you use the whole number times your denominator plus the numerator. And then use it as a new numerator. Okay. Now in lesson 6, we have to take a look at the fraction with different denominator. So let's recall, how do we find the common denominator? Christelle? Okay, you choose a larger denominator first, and then you list down its multiples, and then? Excellent. Then you check if the small denominator 8 is also divisible. Okay, so let's take a look at an example here. How do we find out their common denominator? Christelle? We list down 20. The multiple of 20. 20. Now, then we check if they are multiple of 5 or 50. No. 40. No. 60. Yes. So you need to make this 15 and 20 all to 60. Richard, can you tell me? For this 14 over 15, how do we make it to a fraction with 60 as denominator? We'll make this number to 60.
15 times 4.
Oh, perfect. 15 times 4. What is 14?
14 times 4.
14 times 4 also. And then to give us 60, and this number is 56. So always remember to not skip this step for now, okay? And then for 17 over 20, this is this side, can you tell me how to make this to 60?
20 times
20 times 3,
17 times
20 times 3. This will give us 51 over 60. Okay, so that's how you make a find common denominator. Then we'll take a look at fraction comparison. Now let's recall. In fraction comparison, there are three special scenarios, right? When your denominator is the same, you should compare which number? You should compare the numerator. The larger numerator is, the larger your value is. Then if you have the same numerator, different denominator, then the larger the denominator is, the smaller your value is. And also, in the mixed number, the larger the whole number is, the larger your value. But if your whole number is the same, then you need to compare the fraction. Okay? Let's do a quick calculation here. Bernice, can you tell me? For this one, larger or greater, larger or smaller? 7, 18 is larger or smaller? Smaller, perfect. How about this one? Let's observe. Numerator is the same. Then you should compare the what? Denominator. If the denominator is larger, it means the number is smaller. Perfect. So this one is larger than 6 over 25. Then how about this one? First of all, if this is an improper fraction, we need to convert it to a mixed number. So to mixed number is actually, let's say, 3 and 1 over 3. Okay, is that so? 3 and 1 over 3? No, it's 4 and 1 over 3. So how do we compare these two numbers? You see, if we are comparing the mixed number, the larger the whole number is, the what the value is. The larger. So if your whole number is larger, directly you don't need to compare the fraction. This one is directly larger than the next one. Okay. And then we'll take a look at fraction addition. Now let's recall, in fraction addition, when your denominator is the same, how should we do the addition? The denominator is the same. What should we? How do we add the fraction? Add the numerator, excellent. But what if your denominator is not the same? Yes, if your denominator is not the same, then just find the same denominator. Okay, so these are the two steps. Then I think that's all for the revision. Next, we'll have a 1 hour quiz. The 1 hour quiz. So let me explain to you how the quiz works. For this quiz, it contains 10 questions and 1 extra question. So the full mark is 100 marks. If you made some mistake in the previous questions, but you have attended this extra practice, then the extra practice will award you an extra 10 points. But the maximum number is 100 points. So for example, if you get, for example, 95 points in the previous questions, then you attempt this extra practice and you get it correct, then you have 100 points. Okay? So let's go. You have 1 hour to finish this practice. Oh, by the way, Richard, can you sit one chair next to one chair to the left? Because it's okay.